Look at these hillsides surrounding Jerusalem. At first glance, a place like Sataf looks completely chaotic, a random scattering of trees, rocks, and ancient stone walls clinging to the steep slopes. But building a civilization here presents a massive geological problem. There is no Nile River to flood the fields. There is no Tigris or Euphrates to supply endless fresh water. So how do you sustain thousands of people in an arid, rocky environment? Despite those conditions, ancient farmers managed to cultivate massive yields of wheat, barley, grapes, and olives, the legendary crops of biblical agriculture. They pulled this off without relying on a single major river. Instead, they relied on a system of survival dictated by the physical layers of the hill, from the composition of the rock to the pull of gravity at specific altitudes. To see how they engineered life out of the dust, we have to read the landscape vertically. We need to start at the absolute peak of the mountain and work our way down. We start at the peak. The very top of the hill is the empty zone. It is far too dry to support a permanent farming village. Instead, these peaks were strictly reserved for military outposts, fortresses, and lookout towers. Rain does fall up here, but it vanishes into the earth almost instantly. That's because the top layer of these hills is made of porous sedimentary limestone. The rock is riddled with holes, cracks, and caverns. This diagram shows exactly what happens inside the mountain. The entire upper hill acts like a giant sponge. Rainwater enters the stone and seeps deep down through the cracks, entering a zone known as the aquifer. But the water doesn't sink forever. It slams into a dense, completely impermeable layer of rock called an aquiclude. The downward journey stops. Trapped above this hard rock line, gravity and the water's pressure force the liquid to travel sideways, seeking an exit. This pressure forces the water to burst straight out of the side of the hill. Geologists call this a karstic spring. The internal geology of the mountain is a hidden, naturally functioning water pump, and exactly where that spring erupts dictates exactly where human life can exist on the outside. Finding the spring is step 1. Step 2 is building your town. Ancient builders followed a strict rule. You never build your village below your water source. If you put your houses below the spring, you have nowhere left to put your crops. In a world without motorized pumps, farmers needed gravity to pull the spring water steadily downward, funneling it through a network of carefully carved agricultural terraces. This creates the sweet spot. Look at how this modern settlement mirrors the ancient layout. The houses set 1/3 to 1/2 of the way up the hill, positioned directly above the waterline, leaving the lower slope open for crops. The placement of these settlements was a physical requirement. Each town was pinned to the exact spot where the mountain's geology made life possible. Moving down the slope from the village, the rules of elevation become even tighter. Specific altitudes dictate exactly which plant species can survive, hinging largely on a single critical boundary, the 800-meter snowline. Above 800 meters, heavy winter snows are common. If you plant olive trees here, the accumulating snow snaps their brittle branches, rendering them completely unviable. Instead, the grape is the king of the high elevations. Vines thrive in extreme temperature fluctuations. They need the punishing heat of the summer, and they easily survive the bitter, freezing bite of the winter snow. Below the 800-meter mark, the climate shifts. Safe from the crushing weight of heavy snowfall, these sprawling ancient olive trees become the undisputed dominant crop of the mid-hill region. Down near the very bottom, in the hottest part of the valley, we find the fig tree. To survive here, the fig relies on a bizarre biological anomaly. The fruit is actually an inverted flower. To pollinate it, a highly specialized kamikaze wasp must force its way into a tiny opening at the base of the fig. The tight squeeze rips the wasp's wings off. It delivers the pollen, dies inside the fruit, and is completely consumed by the plant's internal enzymes. From frost-resistant grapes on the peaks to wasp-eating figs in the valley, every single plant species is perfectly engineered for its specific vertical tier on the mountain. That highly calibrated ancient balance contrasts sharply with what happened in the 20th century. Look at these dense rows of pine forests clinging to the hillsides. The original intent was to rapidly green an area that had been left barren for decades. But pine trees are deeply selfish plants that disrupt the natural vertical order. They grow tall, blocking out the sun. They drop millions of acidic needles that create a toxic carpet, killing the local flora below. And because they shed so much dry material, they create massive, fast-moving fire hazards across the entire slope. Overriding the mountain's natural vertical logic with artificial solutions comes with severe, often destructive consequences. When you zoom out and look at the entire terraced landscape of Setauff, the illusion of randomness disappears. This is a highly calibrated, vertical survival machine. Every element relies on the specific behavior of the water inside the stone and the exact elevation of the sun and snow on the outside. In this environment, geography is destiny. Every ruined fortress wall, every planted vine, and every village foundation was placed with exact life-or-death precision. Understanding these vertical relationships transforms a simple hike through the hills into a reading of the Earth's historical blueprint.